Welcome to my part 4 of presentation, a continuation of the previous of the topic sampling. Actually, we are now in the estimation. Is a continuation or a combination of the part of sampling. So I left my presentation previously at the characteristics of a good estimator. Now I'll highlight them. Now it will be a responsibility as a student to make sure you explain them. So characteristics of a good estimator, number one, should be, the estimator should be what? Unbiasedness. It should be free from unbiasedness. Number two, consistency. The estimator should be consistent. Efficiency. The estimator should be efficient. Then sufficiency. The estimator choose to be used must be what? Sufficient. Then I'll be going so fast because this topic, a part of this have already been covered in the hypothesis testing. Now, confidence interval, I also have an idea, this one you have been taught in the hypothesis testing. Now, confidence interval and limit. Now, let's define what a confidence limit is. Now, confidence limit is the average of value within which we may be confident that the population mean does lie. It is the average of value within which we may be confident that the population mean does lie. When we talk about population mean, we talk about mu. I already explained that in my previous presentation. And the confidence interval is the interval between these limits. The interval between these limits is what we call the confidence interval. So when we read this confidence interval will be given in the normal distribution table. Normal distribution table. There are so many confidence intervals that we can use, but mostly under this, they always prefer to use 95% confidence interval or 99% confidence interval. Now when you're given 95% confidence interval, that will be, alpha will be 0.05. 99% confidence interval, alpha will be what? 0.01. Now when you check this into your normal distribution table, at 95% confidence interval, the value you get there for sample mean will be 1.95. Because it's 1.95 or 1.96. It's supposed to be 1.96. 1.96. Then at 99% confidence interval or alpha 0.01, your sample will be given by what? 2.58. So these values are already available at the normal distribution table. So you'll be given a normal distribution table where you'll be checking. So just know it, anytime you're given 99% confidence interval, your value for sample mean will be what? 1.96. Then at 99% or alpha 0.01, your value will be 2.58. Now, estimation of the population mean. Now, I think this is the mathematical part of this one. So I'll give you the procedure for how are we going to calculate the population mean. And the procedure number one, I'll be having at least 5 procedures. Then we'll do 2 examples, then we'll summarize our topic. Now, how do we estimate the population mean, or how do we calculate the population mean? Procedure number 1, take a random sample of n item, and this is an NB, and that n should not be less than 30. And remember in hypothesis testing, you are taught when n is greater than or equal to 30, and when n is less than or equal to 30, you can know the sample size. That already has been covered in the hypothesis testing, so I won't stress much about it. Now with this one, you just take a random sample of n item, but make sure n is not less than 30, meaning n must be greater than 30. Then step number 2, complete the sample mean. No, compute the sample mean. Compute stroke calculate the sample mean. What's the sample mean? From the table I gave you, our sample mean will be what? X bar. X bar we can compute it, but we'll compute it in our topic of measure of central tendency. But in this scenario, in most of the question, the sample mean you'll be given. But if you ask to compute, now X bar, I'll tell you more about this one in the topic of measure of central tendency. Now X bar is always given by what? Summation of fx over n, where n is always what? Summation of f. So x bar can as well be summation of fx over summation of f. But that is in a scenario when you're asked to compute x bar. But in most of the cases, in the estimation of population mean, you'll always be given that sample mean. Now compute the sample mean and the standard deviation. of the sample. So you compute the sample mean, the standard deviation of the sample, which is given by sigma x. Number 3, compute the standard error of the mean with this formula. So this is how we are going to compute the standard error. That is sigma sample mean is equal to what? Sigma x over root n. Sigma x bar is equal to sigma x over root n, where sigma x bar stands for standard error of the mean, where sigma x bar, this stands for sigma. Sigma means standard deviation, x bar means what? Sample mean. So sigma x bar means sample mean and sample standard deviation. Sigma x bar will give us what? Standard error of the mean. Then sigma x will stand for standard deviation of the sample. N is the number of what? Sample size. Hope you together. I'll repeat again. Sigma x bar stand for error is the standard error of the mean. Then sigma x is the standard deviation of the sample and the sample size. Then step number 4, procedure number 4. Choose the confidence level, e.g. 99% or 99%. I've told you something about confidence level. Also, that confidence level will be given in the question. They'll say maybe take a confidence interval of 95% or 99%. We've known. Mark this, Wakiliako. When you ask 99, when it is 95%, our sample will be 1.96. When it is 99, it will be 2.58. Now choose the confidence level, e.g. 95% or 99. Then step number 5, estimate population mean as shown below. Now these are how we are going to estimate population mean. That will be population mean is equal to x bar, that is sample mean, plus or minus appropriate number of what? Standard deviation of the sample. Example, let me indicate it, example 1. With mathematics, we must do it mathematically when you can understand. It's very hard to understand it theoretically. Now let me read my example. Example 1. A certain type of wire are normally distributed with a standard deviation of 200 kilograms. Full stop. A random sample of 64 specimen gives a mean of 6,200 kilograms. Find out the population mean at 95% confidence level. Find out the population mean at 95% confidence level. So solution. Now how do you calculate our population mean? Now mean will be given by what? X bar plus or minus. Never forget this plus or minus. 1.956 times what? Standard deviation of sample. So it is x bar population mean is given by mu is equal to x bar plus or minus 1.96. Now where do you get the 1.96? Because in the question we will be given that we take our confidence interval to be 95%. And I've told you when the confidence interval is 95%, so alpha is 0.05, then our sample mean will be 1.96. So that's why I'm taking my x bar sample mean plus or minus 1.96 times the standard deviation for the sample. Now, let me dissect my question. Now, what will be our x bar, sample mean, in the question? Now, certain type of a wire normally distributed with a standard deviation of 200 kg. So, already shapata sigma x is 200 kgs. And a random sample of 64 specimen. Random sample, meaning that is n. Now, our n will be 64. Random sample of 64 specimen, so our n will be 64, gives a mean of what? 6,200. So the standard deviation of sample mean will be what? 6,200. The standard deviation of sample mean will be what? 6,200. Now how do we calculate? How do you compute what? The standard error. First we have to calculate the standard error. Now how do we get the standard error? Because in this formula of calculating what population mean it will be mu times x bar sample mean plus or minus 1.96, that is confidence interval, times what? This is times, let me say standard error. Not standard deviation, standard error. And we know that standard error is given by what? Sigma Standard error is given by sigma x bar. Yeah. And the standard error is given by what? Sigma x bar. So it is mu is equal to x bar plus or minus 95% confidence interval, which is 1.96 times standard error, that is sigma x bar. So meaning in our question we have the standard deviation. We have the standard deviation for the sample mean, we have the number of sample, then we have the standard, then we have what? We have the standard deviation for the sample, which is 200. Now what we are missing is what? The standard error, which is given by sigma sample mean. So how do you calculate standard error? Standard error is given by what? Sigma x over root n. Now come here, sigma x over root n. What's our sigma x? Now sigma x will be what? There's a difference between sigma x bar and sigma x. Sigma x is the standard error, then sigma x is the standard deviation of the sample mean. Now we take sigma x, which is 200, divided by root n. Our n is 64, so that is 200 over root n. When you compute it, we'll get what? 25. So already now what we were missing in this question was standard error. Standard error as what? 25. So this will be sigma x bar, which will be what? 25. Now we want to calculate population mean. We know that population mean is given by mu is equal to x bar plus 1 plus or minus 1.96 times what? Standard error. Mu is equal to x bar plus or minus 1.96 times standard error. Now what's our mu? Now we are calculating mu. Now what's our x bar? Already we have x bar, x bar is the what? The standard sample mean, 6,200 plus or minus confidence interval of 95% interval, that is 1.96. That will be plus or minus 1.96 times what? The standard error that we have calculated, which is 25. So it is 6,200 plus or minus 1.96 times 25. Now remember to always keep the plus or minus. We can always negate the output, meaning make it positive. So we'll take it plus or minus 6,200 plus 49. So we'll compute the other part with the positive and the other part with the negative. So meaning our answer will range from what? When we do the positive, we'll get what? 6151. And when we minus it, we'll get what? 6249. So our answer will be ranging from between 6151 to 6249. And that will be our what? Population mean. The last example, we want to estimate what? The population proportion. So this was the population mean, the other one the population proportion, and that will mark the end of my topic. So let's do something about the estimation of population proportion. So population proportion, pia tunatafuta what? Standard error of the sample proportion. Kumbuka huko tunatafuta standard error of the sample mean. So here we were calculating standard error of the sample mean. Huko tunatafuta the standard error of the sample proportion, SP. So huku it was kinini sigma bar, kule the sigma proportion. Know the difference. Now how do you calculate? Population proportion. So sigma, standard error of the proportion will be given by what? P dot Q, P times Q over what? N. Then we get the root. The root of PQ, P times Q over root N. So we just take the proportion times Q divided by what? N. Then P we know is the population proportion. Now how do you get Q? Now Q will be given by what? 1 minus P. Q will be given by 1 minus P. And I remember also this one you may find a test of hypothesis, so I won't go deeper. And N is the sample size. So Q will be given by 1 minus P. P is the population proportion and N is the sample size. Now, standard error for the sample proportion will be given by P times Q over N, then get the square root. Example 2, then we finish. In a sample of 800 candidates, 560 were male. Estimate the population proportion at 95% confidence interval. In a sample of 800 candidates, 560 were male. Estimate the population proportion at 95% interval. So first of all, you need to get sample proportion. That is P. Sample proportion, that is P. So we have what? 800 candidates, of which 56 of them, 560 were men. So we are getting proportion. So proportion we just divide. Now we take the value of the men divided by the total number of the candidates. So that will be 560 over 800, giving our sample proportion to be what? 0.70. So our P will be 0.70. So already we have calculated P. Then remember Q is 1 minus 0.7. Q will be 1 minus 0.7. So when we take 1 minus 0.7, 1 minus 0.7, 1 minus 0.7, then our Q will be what? 0.30. So already we know our P is already given by what? 0.70. Q will be 1 minus 0.7, making our Q to be what? 0.30. Then N already has given the sample of 800 candidates. So our N will be 800. So what do? We calculate the standard error of the sample proportion given by this formula. Standard error of sample proportion is given by PQ over N, then we get the square root. Now we have P, our P will be 0.70 times Q, which is 0.30, divided by sample size N, which is 800, then we get the square root. So when you calculate all this, your sample error proportion, your standard error sample proportion will be 0.016. So that is standard error of sample proportion. But the question is asking you calculate what? We have to calculate population what? Proportion. So in order for us to calculate population proportion, it will be given by what? P plus or minus 95% confidence interval, that is 1.96 times standard error of the sample population, that is sigma P. Same to calculating population mean, we are given by X bar, that is sample mean times 1.96 times standard error of the sample mean. They're just the same, but the terms have now changed, but the same thing. It is a population proportion P, so here it was X bar, plus confidence interval maintained the equal, then a standard error of sample proportion. So what's our P? Then we have our P, which will be 0.70 plus or minus 1.96, that is the confidence interval, times the standard error that we have calculated, which is 0.016. So it is plus or minus. When you calculate it, our answer will be ranging from 0.67 to 0.73. And that will be our population proportion. So thank you for listening to me and also taking notes. I'll send an assignment. In my next class, part 5 for my presentation, I'll give an assignment on the same so that you can try it where you are. Thank you so very much. See you next time.